Chapter 7, Confidence Intervals and Sample Size. Hello classmates, I am Joanne Orang, now here to report or share my knowledge about this chapter. My topic is all about confidence interval for the mean when standard deviation is known and sample size. So, first, point estimate. It is a specific numerical value estimate of a parameter. It provides an estimate of the value of the parameter based on the available sample data nga ato ang gina-collect. For example, if we want to estimate the population mean, a point estimate would be a single number that represents our best guess for the true population mean. In case of estimating the population mean, the best point estimate is the sample mean. You would ask ngano dili median, ngano dili mode. Sample mean jud. The sample mean is calculated by taking the average of all observations in a sample. It is considered the best point estimate because it is unbiased estimator of a population mean. This means that on average, the sample mean will be equal to the true population mean. The sample mean is often used as point estimate for the population mean because it is easy to calculate and provides a reasonable estimate when the sample is representative of the population. However, it is important to remember that the sample mean is just an estimate and may not exactly match the true population mean. That's why we call this point estimate. When we say estimate, isn't approximately something like that. So, ito na to sa the estimator should be unbiased. So, sa word nga biased or unbiased. So, bias refers sa tendency of an estimator to overestimate or underestimate a parameter. So, it was said na unbiased estimator. So, it doesn't systematically overestimate or underestimate the parameter. For example, consider estimating the average height of all people in the city. If your method of estimator tends to give values that are consistently higher than the true average height, perhaps because your sample includes more basketball players than the general population, then your estimator is biased. But I want you to note nga, being unbiased estimator, dili lang siya gamin nga accurate siya every single sample. It's possible for an estimator to be unbiased on average. Average lang siya, but still be far off from the true value for any individual sample. Unbiased kay kanang dili siya layo sa dili siya layo sa true population nga unsa na sample, hapit-hapit lang. Kung mingon mong tag bias kay na sobraan og sobraan ang unsa na pag-estimate nato or na kulangan. Sobra kaayo, kulang kaayo. So when you say unbiased, sakto-sakto lang. That was the first. So second, the estimator should be consistent. Additional consistent. For a consistent estimator, a sample size increases, the value of the estimator approaches the value of the parameter estimated. In other words, the probability that the estimator will be close to the true parameter value increases as the sample size increases. Kung magsigig kadugangan ang sample magsigig increase ang sample size, magkaduol ta sa ato ang true parameter value kaya makuha na bitaw jud nato ang tinuod nga unsa na true parameter value gani. It is desirable property for an estimator to have it because it ensures that we are getting more accurate estimate as we collect more data. More data, makakuantang ay kini mag just like a gathering information, more data ana more data daghang tag knowledge nga mag-gain mas investigation Japan siya bang makakamap na to ang exact nga itong ginapangita. Third, The estimator should be relatively efficient estimator. I'll just read it, ha. That is, of all the statistics that can be used to estimate a parameter, the relatively efficient estimator has the smallest variance. Efficiency is a relative concept in statistics. An estimator is more efficient than another if it has smaller variance. So, the more efficient we are, the more precise ang estimates possible from our data nga kina-collect. So, those are the three properties of a good estimator. First is the estimator should be unbiased. Second, the estimator should be consistent. And the third is the estimator should be a relatively efficient estimator. Move. An interval estimate of a parameter is an interval or a range of values used to estimate the parameter. So, ganina, atong ginakuan kay point estimate, now is interval estimate. This estimate may or may not contain the value of parameter being estimated. So, it has been said nga, range of values. Unsaon mo na to pagkuha sa range of values? Of course, ang highest ato ang subtract sa lowest nga na lowest number sa sample. The confidence level of an interval estimate of a parameter is the probability that the interval estimate will contain the parameter, assuming that a large number of samples are selected and the estimation process in the same parameter is repeated. Next, confidence interval. A confidence interval is a specific interval estimate of a parameter determined by using data obtained from a sample and by using the specific confidence level of the estimate. So, confidence interval kay na muna ni siyang gipag na tong point estimate ganin na tong interval estimate. Kay gayus man siya data obtained from the samples, tapos nagkuha na siya steps. So, muna siya formula for the confidence, must take note ni siya nga na, ha. Diri siya nga i-take note ninyo kay samat manggod kay ang dapat we should memorize the formulas para dili bitaw wrong atong answers. Kasi kung wala ta kabalo sa formula, hindi natin alam yung solution on how to get the answer. So, formula for the interval of the mean for a specific standard deviation. So, sample mean minus na siya. For 90%, ato na yung i-take note po dire, for a 90% confidence interval, ZA2 is equal to 1.65 for the 95%, 1.96 for a 99%, 2.58. So, applying the formula, man siya. Dapat we should get the confidence na 95% mean. Maximum error of the estimate. I'll give you an example later, no? Basig makon wala example, sige taganta mo example later. The maximum error of the estimate is the maximum likely difference between point estimate of a parameter and the actual value of the parameter. So, muna siyang all we have to do is know the formula para dili ta mawala. Confidence interval for a mean. Rounding rule. When you are computing, muna siya to ang kadang rounding rule. Kung gamit ang like natay mga pod 1.96 ba 1.9678944 ana kana dapat natay muna siya ang rounding rule nga ato ang kailangan sundon. When you are computing a confidence interval for a population mean by using raw data, round off to one more decimal place than the number of decimal places in the original data. So, 1 decimal places lang. So, 1.96, imuha na siyang, sige, 1.86 na lang. hangyo. So 1.86 ato ang yun sana i-round off into one decimal kuan lang isa lang siya ka number sa decimal. So 1.86 butang siya 1.9 kay 6 is pwede man siya ma-round off 1.9. So kaduha, when you are computing a confidence interval for a population mean by using sa kwanto siya sa raw data to siya karon sa sample mean and standard deviation round off to the same number of decimal places as given for the mean. So this same decimal places, so mura to imong ikwan dili na kanong more etc etc. So here's the example for my report. Days to sell an Aveo. A researcher wishes to estimate the number of days it takes an automobile dealer to sell a Chevrolet Aveo. A sample of 50 cars had a mean time on the dealer's lot of 54 days. Assume the population standard deviation to be 6.0 days. Find the best point estimate of the population mean and the 95% confidence interval of the population mean. So, the best point estimate of the mean is 54 days. So, para dili ta malibog no, kailangan nato i-take down note ang mga ang mga kuan para pag mag compute na ta dili na ta mo siya unsa ito ang sample mean, unsa itong deviation, unsa itong numbers, unsa itong z's ato, unsa itong 95%, wala dili na kay ta malibog kay ay makita naman nato sample mean is equal to 54, the standard is 6.0, pila na siya. So using the formula, tada, man siya. Minus lang na mo. Man siya. Should I dictate pa ba? Sige, 54 minus 1.96 na diretso na ni siya, pero this is an important note to everyone no, nga pag mag-compute ka ani nga mga numbers dili sa pag gamit kag cellphone kailangan nimo siya isa-isahon kasi kung imuhang isa-isahon or kailangan jud naka scientific calculator kasi if you're using an ordinary calculator mangud kay imuhang result kay dili siya pareha sa result sa scientific calculator. So kung kailangan ta magsige kuan check sa atong answer kay dili lang ta magpasagad kasi if we think nga sakto naman ni okay mo naman ni kailangan na pud na to otro kay mali jud siya. So mo to examples na lang ni siya using the kuan Japon no ha, using the formula. So there some of you would ask ngano asa man ni nakuha ang 2.33 nga kuan kining table manggod kay sana kamantay mag z table sa kuan sa una sa senior high school mo ni siya ginagamit nga table para magkuha ang maka-came up og ingan na nga sana. So for example nakakuha ka og imuhang kuha nga kuan kay 0.9901. So imuhang pagtan-aw nimo dito amang 0.9901 ato sa ato ang z table nga kuan pagkuan day nimo kay just like a x-axis and y-axis kailangan nimo siya point out kay para makakuha ka og answer. Technology note. This chapter and subsequent chapters include examples using raw data. If you are using a computer or calculator programs to find the solutions, the answer you get may vary somewhat from the ones given in the textbook. This is so because computers and calculators do not round the answers in the intermediate step and can use 12 or more decimal places for computation. So as what I've said kanina, no, nga katong mga calculators or mga cellphones or mga ordinary calculators lang kay medyo dili kanang lahi-lahi bitaw siya ginhatag nga answer because of the decimal places, mga decimal sa pag-round off bitaw sa numbers. So muna na siya. The formula for minimum sample size needed for an interval estimate of the population, where E is the maximum error of estimate. So as ma-recall na to man siya ang maximum margin of error. Maximum error is also known as margin of error. Ano to siya? Muna siya, E. Ang result nimo ana siya, ang result nimo nga number ana mao imong ibutang dito sa ilalim. Tari. Scarot. Pariyaan ni kuha niya daan write down niya daan ang mga numbers para dili na siya malibo. And that's all. Thank you. I hope na ka-learn mo sa akong giingon, sa akong gipang share ng mga knowledge niyo. Thank you. God bless.
Hello everyone, for today's video, I'm going to discuss my designated topic under the chapter 7, which is the confidence intervals for the mean when sigma is unknown. By the way, I am Ms. Grace M. Umayan, BPA 3, Section 2. So, let's start discussing what is the confidence intervals for the mean when sigma is unknown. If the population standard deviation or the sigma is unknown, the process for finding a confidence interval for a sample mean relies upon the student t distribution. So, kung sa katong last nga topic nga kung known ang ato ang standard deviation, atong gamiton kay ang z distribution. However, kay unknown man ang ato ang sigma or the standard deviation, ato ang gamiton kay ang student t distribution in order to find the confidence interval for a sample mean. So, ang student t distribution mo nato ang sources or mo diri ta mag-rely aron makuha nato ang ato ang solving. So, the t-distribution is a family of curve, each determined by a parameter called degrees of freedom. So, ang t-distribution is parihara na sa mga curve. However, ang kaning t-distribution na asay degrees of freedom. Kaning degrees of freedom mo determine kung unsa nga curve ang naa sa t-distribution, kung unsa imong ibutang sa t-distribution. When you use t-distribution to estimate a population mean, Vf equals n-1 degrees of freedom. So, kung mogamit og t-distribution na atay, kung distribution ang atuang degrees of freedom kay ang atuang n or ang atuang number or total size of the samples or the observations ato ang isubtract sa 1 in accordance sa iyahang formula nga degrees of freedom equal n-1. So example, ang ato ang n sa ato ang equation nga example n is equals to 22. So in order to get the degrees of freedom, ato na siyang decreasean og 1. So kung 22, so natay 22 minus 1, so natay 21. So atong degrees of freedom kay mauna ang 21. As the degrees of freedom increase, the t-distribution approaches the normal distribution. For 30 or more degrees of freedom, the t-distribution is close to the standard normal distribution. So kaning t-distribution is hapit na sa nagkapariha ni ni standard normal distribution. So if ever nga mogamit ta og ang ato ang degrees of freedom is 30 up 30 plus, is more likely or more closely na sila nga magkapareha ni normal na sa standard normal distribution. Ang normal standard distribution mo to nga bell-shaped iyang form. For example, if the mean of 5 values is 10, then 4 of the 5 values are free to vary. But once 4 values are selected, the fifth value must be a specific number to get a sum of 50, since 50 divided by 5 equals 10. Hence, the degrees of freedom are 5 minus 1 equals 4, and this value tells the researcher which curve to use. So kay diri nga part is ang ato ang n is 5, so ato siyang gidecreasean og 1 in order to get the degrees of freedom nga mao na siya ang 4. So kanang black din nga nga curve is mao na siya ang ato ang T distribution nga which is nga hapit na gid siya naka-form og bell shape. So unsa man nga formula ang ato ang gamiton ing ani nga situation. So the formula for a specific confidence interval for the mean when sigma is unknown and n is greater than 30. So kung wala tatong sigma is unknown siya, nga nang sign dayon ang atong n is greater than 30 siya, so mo na atong gamiton nga formula. X bar minus t sub alpha divided by 2 times s over square root of letter n greater than kanang ragyo nga forma mo nag-represent sa mean population dayon greater than x bar plus na siya na mali t dayon sub a over 2 times s over square root of n. So ang x bar na to mo nag-represent sa mean, and ang t a sub a over 2 mo na siya ato ang t distribution or t value, ang s mo na siya ang sample size sa standard deviation, dayon ang n is the total number of population or the total size of the population. So mo na to ang formula nga gamiton. Supposedly kanang mga letter s nga naa dinha sa formula dapat sigma sign unta na siya diha, kaso lang ang ato ang sigma or ang ato ang standard deviation is unknown man siya, so moong ato siyang substitutehan og letter s. So let us try. So atong first example is find the t of sub alpha divided by 2 or t distribution value for a 95% confidence interval when the sample size is 22. So our solution is the df or the degree of freedom equal 22. So para sa akong giingon ganina, kung magkuha ta degrees of freedom, ang ato ang sample size or ang ato ang n nato is ato ang decreasean og 1. So 22 minus 1 is equal to 21. So muna nga to ang degrees of freedom mo ng 21. After that, find the 21 in the left column and the 95% in the row labeled. Confidence intervals. The intersection where the two meet gives the value for t sub a divided by 2, which is 2.080. So as you can see in the figure 7 to 7, so ang kanang table if is kuan na siya kanang given na siya, yun, ang imo na lang buhaton is pangitaon nimo ang intersection anang duha sa imuhang 95% confidence interval. So pangitaon nimo ang 95% confidence interval, so pangitaon mo si 95%, then sa degrees of freedom dayon nimo diha din nimo pangitaon nga nakalinya ang imuhang degrees of freedom, which is the 21. So ang intersection anang duha sa imuhang 95% og sa imuhang 21 is mao na ang value nga imong gipangita for the t alpha divided by 2 mo na siya ang ato ang gipangita nga value dinha. So the value for 95% confidence interval when the sample size is 22 is 2.080. So mauna na siya nga ato ang answer for finding the t value sa ato ang sa ato ang kuan example. So muna siya nga so ang 2.080 muna na siya ang ato ang answer kung pangitaon nato ang 95% confidence interval kung ang ato ang sample size is 22. So pareha sa akong gikuan ganina nga kung ang ato ang sample size is 22, ato nang decreasean og 1. Always remember that our degrees of freedom equals n minus 1. So mo din natong pangitaon sa ato ang the T distribution table. Dito din nimo makita dayon nimo sa column nimo makita ang imong 95%, diya sa column nimo pangitaon kung pila ang iyang confidence interval. Dayon sa row dayon nimo makita sad kung unsa ang mga number nga naka-indicate dito for your degrees of freedom. So ang imo harang, so this one is imo rang i-keep on mind, pangitaon ra nimo kung asa ang confidence interval ug unsa ang imuhang degrees of freedom. Then imo din nang ikuan ang duha intersection like sa kanang naka-red nga cross line dira. Sa cross mo na siya nga kung ang intersect nila nga number mo na dayon na ang answer sa ato ang gipangita sa TA2 kung ang ato ang 95% confidence interval kung ato ang sample size is 22. So our next example is sleeping time. 10 randomly selected people were asked how long they sleep at night. The mean time was 7.1 hours and the standard deviation was 0.78 hour. Find the 95% confidence interval of the mean time. Assume that the variable is normally distributed. So in ani nga case, first ginato nga atong i-identify kung unsa ang given. So atong given here is the 7.1 hours nga mean nato mean. Dayon ang atong standard deviation nga 0.78 hour. So atong pangitauno na lang is the 95% confidence interval of the mean time. So ato din tong para sa akong giingon ganina nga ato ta dito sa ato ang distribution table nga given. So ato nimo dito pangitaon nimo ang ato ang n first. So ang atong n there is 10 randomly selected people, so 10 kabuok. So as I said ganina, kung magkuha ta sa degrees of freedom is ang atong 10 minusa nato og 1 kay mo man na iyang formula. So apparently ato na lang degrees of freedom is 9 na lang. 9 degrees of freedom nga makita nato do sa atong table nga iyahang 95% confidence interval kay mao ang 2.262. Then after nga nakuha na nato si 2.262 sa dito sa ato ang T distribution table, ato na din na siya nga ipang substitute sa ato ang formula. So our formula is katong motong nga x bar minus t sub a over 2 times s over square root of n greater than katong mean, represent sa mean population, greater than x bar plus t sub a over 2 times s over square root of n. So ato ang mean din ha, atong x bar, di ba mean man na siya. So ang mean nato din ha is 7.1 hours. So ang mga x bar dira ato nang substitutan og 7.1. Then ang kanada yung t sub 8 divide to mo na siyang ato ang t table value, atong t distribution value ganina nga nakuha nato, which is the 2.262. Then ang s nato ay stand for the standard deviation mo ng 0.78. Ang n nato nga 10 kabuok randomly selected people. So atong 7.1 minus 262 0.78 over square root of 10 greater than mean population of mean greater than 7.1 plus 2.262 times 0.78 over square root of 10. So after that ato na din siyang i-simplify. So 2.262 times 0.78 over square root of 10. So first natong step kung mabot tag simplification is kailangan nato ang PEMDAS nga method. So muna siya ang parentheses, exponent, multiplication, division, addition, and subtraction. So namatay parentheses no. So first we're gonna break down the parentheses. So ang square root sa 10 i-divide yun nato siya i-divide sa 0.78 then i-times sa 2.262 mo nang nakakam up ta og 0.56. Ingana ihapon dinhi sa pika side nga ang 2.262 times 0.78 over square root of 10 mo na siyang nakakuha pihapon ta og 0.56. Then 71 minus 0.76, it's come up to 6.54. Then ang 7.1 plus 0.56 mo din ang nakakam up rin og 7.66. So therefore, one can be 95% confident that the population mean is between 6.54 and 7.66 inches. So, ing ana ra siya pagkuha if our standard deviation is unknown. So students sometimes have difficulty deciding whether to use Z or T values when finding confidence intervals for the mean. As stated previously, when sigma is known, Z values can be used no matter what the sample size is, as long as the variable is normally distributed or n is greater than 30. When sigma is unknown and n is less than 30, then S can be used in the formula and T values can be used. Finally, when sigma is unknown, n is greater than 30 is used in the formula and T values are used as long as the variable is approximately normally distributed. So, ato arang hinumduman nga og mogamit tag Z values or T values is kung Z values, if our standard deviation or our sigma is known, muna mogamit tag Z values. However, kung ang sigma or standard deviation is unknown, muna mogamit ta og T values.
This is Desiree Joy Panlaan. So my topic is all about confidence interval and sample size for proportion. As what they've said, confidence interval is a range of values that is likely to contain the true value of population parameter, while the sample size, it is the number of observation or individuals included in the sample. From the word itself, size no kay ga-consist jud siya og numbers. Upon estimating the proportion, ang paggamit sa confidence intervals o pagdetermine sa tamang sample size, importante kayo aron makakuha og reliable and accurate nga mga results. Though it has been said kanina about the confidence interval and sample size, but ako lang siyang gi-recap. So let's move on. This topic kay gakuan lang siya og mga formulas about the unsaon pagkuha sa sakto nga unsa na. Now, P is equals the population proportion. P hat is the sample proportion. For sample proportion, P hat is equals to X divided by N, and Q hat is equals to N minus X minus N, or Q hat minus 1 minus Q hat is equal to 1 minus P hat, where X is the number of sample units that possesses the characteristics of interest and N is equal to sample sizes. Example: air-conditioned household. In a recent survey of 150 households, 54 had a central air conditioning. Find P hat and Q hat, where P hat is the proportion of households that have central air conditioning. Since X is equal to 54 and N is equal to 150, so using the formula, P hat is equal to X minus N. So, nakuha na nimo ang mga X ug N. 54 divide 150 is equal to 0.36. I-convert din nimo siya into average is equal to 36%. Ang Q hat naman is equal to 1 minus P hat is equal to 1 minus 0.36 is equal to 0.64. Tapos makakuha siya into times nimo siya 100% is equal to 64%. For formula for a specific confidence interval for a proportion, P hat minus Z alpha divided by 2 square root of P hat and Q hat divided by N is equal to less than or P hat plus Z alpha divided by 2 and square root of P hat and Q hat divided by N when N and P is is greater than or equal to 5 and NQ is greater than or equal to 5. Rounding rule. So, nanapunta sa rounding rule, round off to 3 decimal places. So, if imuhang points kay 9.1679, mo na siyang ma-round into 168 since ang 9 kay greater man siya sa na. So, here's the example. A survey of 1,721 people found that 15.9% of individuals purchases religious books at a Christian bookstore. Now, this is the problem. Find the 95% confidence interval of the true proportion of a people who purchase their religious books at a Christian bookstore. Using again the formula that has been given, kani siya, formula for a specific confidence interval for a proportion. P hat minus Z alpha divided by 2 square root of P hat and Q hat divided by N and P hat plus Z alpha divided by 2 square root of P hat and Q hat divided by N. Now, kuan na nimo siya no, nabutang na nimo siya na find na nimo unsay pilay halaga sa unsay number sa P hat, unsay kuan sa Z alpha ana. Kay 95% man sa ilang giingon sa nasa report ni Jo ang 95% is equal to 101.96. So, using the formula again, muna siya gikuha nimo. 0.142 muna siya ang na-come up niya. Next, formula for minimum sample size. So, kung ganina, formula to sa specific confidence now, dere, sample size na, minimum sample size needed for interval estimate of a population proportion. N is equals to P hat and Q hat times Z alpha divided by 2 divided by over margin of error squared. If necessary, round up to the next whole number. So, whole number man siya, nag-expect tag walay point. Yeah. Example, muna siyang example sa minimum sample size. A researcher wishes to estimate with 95%. Meaning, ang 95% do, sa giingon ni sa nasa report ni Joan, ang 95% is equal to 1.96. Muna siya tong timanan per me. With 95% confidence. The proportion of people who own a home computer. A previous study shows that 40% of those interviewed had a computer at home. The researcher wishes to be accurate within 2% of the true proportion. Find the minimum sample size necessary. Using the formula, kuan na nimo, gisegregate na nimo 0.40 ag 0.60. So, as what we've noticed no, kay ihang result kay 2,304.96 sa gingon ganina kay dapat i-round off nimo siya into whole number. So na the researcher should interview a sample of at least 2,305 people. So 2,304.96 i-round off nimo into whole number is 2,305. Gets? And the end. Thank you.
Hey everyone, so my report is about confidence intervals for variances and standard deviation. So this topic is about how to calculate and the means and the proportion This section will explain how to find confidence intervals for variances and standard deviation. In statistics, the variances and standard deviation of a variable are as important as the mean. So, example is the products that fit together, such as pipes, are manufactured. It is important to keep the variations of the diameters of the product as small as possible. Otherwise, they will not fit together properly and will have to be scrapped. In the manufacture of medicine, the variance and standard deviation of the medication in the pills and an important role in making sure patients receive the proper dosage. For those reasons, confidence intervals for variances and standard deviation are necessary. So technology step by step. So in finding confidence interval for the variance and standard deviation for data, here are the step by step how to find data or use data. So number one is enter the data values into L1. Second is press PRGM. Move the cursor for the program name SDINT and press enter voice. Third is press 1 for data. Fourth is type L1 for the list and press enter. Then fifth is type the confidence level and press enter. Then sixth is press enter to clear the screen. So that is the step to how to find interval for the variance and standard for the data. So in finding a confidence interval for the variance and standard deviation, statistics na sad ni. So kani siya 6 gyapon sila kabuok pero lahi-lahi sila unsaon pagkuha sa unsaon pagpangita sa confidence interval for variances. So akong basahon is number 1 is press PRGM. Move the cursor to the program name is DINT and press enter twice. Second, press 2 for stats. Third, type the L sample standard deviation and press enter. Type the sample size and press enter. Fifth is type of the confidence level and press enter. And sixth is press enter to clear the screen. So as you can see sa inyong screen, makita ninyo nga lahi ang pamaagi sa data, lahi sa pamaagi sa statistics sa pagpangita sa confidence interval for the variance and standard deviation. So sunod is in the summary, ang diri important is how to estimate the proportion of population and accompanied by selecting a random sample from the population and choosing the outcome statistic that the best estimated. So diri pod makita nimo mabala na to nga estimation is the key. Estimation is the parameters of population nga accompany sa diri kinahanglan nato mag-research through population. Diri makita nato kung unsaon ma-estimate nato nga makuha nato ang atong gusto nga ma-estimate. Example is like grocery, naatay ka ng budget niya. Natay gina-estimate nga budget niya kana diya ra kutob atong mapalit sa atong grocery. So diya makita nato magamit nato ang atong pagka-researcher mag-ato ta sa mga grocery atong tagsa-tagsaon gyud ang mga grocery kung asa ta maka-save, kung unsa ang mas barato, kung asa ta maka-save. So matawag ra gyapon nato kung kaugalingon niya kita ang researcher pero lahi ta nga population ni adto which is mga groceryhan ta ni adto kay para maka-save ta rin makuha nato tong estimated budget. Sorry, makuha nato tong estimated budget kay diri man mao man itong ginatawag nga mao ni ang kuan sa tong topic is mag-estimate ta sa budget tapos makuha na to ang research ug ang population. So kinahanglan gyud ta nga mag-estimate sa tanang butang, dili lang sa pag-budget sa kwarta, dili lang sa kuan sa mga butang-butang, kun dili sa tanang butang kinahanglan ta mag-estimate, dili lang kay magpalabit ta, dili lang kay di magkulang ta, kailangan sakto lang dili ihatag natong tanan, dili pud nato kulangan ang tanan kay biyaan man ta charis, ana lang siya. So kailangan estimate dayon gamit og proportion sa population. So that's all, thank you.
This is the continuation topic for the confidence intervals for variance and standard deviation. Confidence intervals were calculated for means and proportion. This section will explain how to find confidence intervals for variances and standard deviations. In statistics, the variance and standard deviation of variable as important as them. So, confidence intervals unsaon pagkuha ni kay pagkuha sa means o proportion. The chi-square variables is similar to the t variable in that its distribution is a family of curves based on the numbers of degrees of freedom. For example, to find the table corresponding to the 95% confidence interval, you must first change 95% to a decimal and subtract it from 1. So, 1 minus 0.95 is equal to 0.05. Kung saan nimo pag-change siya, 95%. 95% para siya gikuan sa 0.95 times 100. Mo nga na ba? 95 decimal point sa 95% is 0.95. Subtract nimo siya 1 is equal to 0.05. Then divide the answer by 2. So a divided 2. So 0.05 divided by 2 is equal to 0.025. This is the column on the right side of the table used to get the values for x squared right. To get the value for x squared left, x2 left, subtract the value of a2 from 1. So 1 minus 0.05 divided 2 is equal to 0.975. Finally, the appropriate row corresponding to the degrees of freedom in 1 and 1. A similar procedure is used to find the values for a 90 or 99%. So, as we've all known na tulo ni sila kabuk mag-igsoon. Joke. Tulo ni sila jud kabuk mag-uban na sige si 90%, si 95% ug si 99%. So, sa steps nga itong gikuan pagkuha sa x squared left ug right, pareha japon sa 90 ug 99%. Formula for the confidence interval for a variance. Formula is the open parenthesis n minus 1 close parenthesis dayon variance divided by x squared right and variance n minus parehara sa left. Example of nicotine content. The problem is find the 95% confidence interval for the variance and standard deviation of the nicotine content of cigarettes manufactured if a sample of 20 cigarettes has a standard deviation of 1.6 milligrams. Since a 0.05, the two critical values respectively for the 0.025 and 0.975 levels for 19 degrees of freedom 1 degrees 32 are 32.852 and 8.907. The 95% confidence interval for the variance is found by substituting in the formula 20 minus 1 times 1.62 divided by 32.852 right. Muna siya ang sa right is equal to 1.5 and 20 minus 1 tapos multiply siya 1.6 multiplied by 2 divided by 8.97 is equal to 5.5. Hence, you can be 95% confident that the true variance for the nicotine content is between 1.5 and 5.5. For the standard deviation, the confidence interval is 1.2 and 2.3. Hence, you can be 95% confident that the two standard deviation for the nicotine content of all cigarettes manufactured is between 1.2 and 2.3 milligrams based on the sample of 20 cigarettes using the formula that has been given. Nga na siya pag come up sa answer. Recall that S squared is the symbol for the sample variance and S is the symbol for the sample standard deviation. If the problem gives the sample standard deviation S, be sure to log square it when you are using the formula. But if the problem gives the sample variances, do not square it when you are using the formula. And that's all. Thank you.